Okay, so today we're going to talk just a little bit more about the electron. What you're going to find is that the electron's a little bit more complicated than what we had talked about before. And when we talked about this before, we talked about the idea of the nucleus being in the center, consisted of protons and neutrons, where protons had a positive charge, and these gray neutrons here are neutral. Um, and so they occupied like 99% of the mass and about 1% of the volume. So we talked about the density, the amount of mass per volume being very, very large because all the mass of the atom is right there in the center. And then out here in this cloud, sort of moving around, and we didn't talk a lot about this, was the electron. Um, and so we want to talk about in a little more detail about exactly what's going on with the electron there. And like I said, it turns out it's a lot more complicated, but we're not going to talk about the a lot part. We're only going to talk about um, some of the details about where we might find an electron. And so, you know, this has been something that scientists have looked at for a long time, and I say scientists because not only chemists but physicists have worried a lot about and thought a lot about where the electron might be located, and we know, or at least have a lot more detail now about where the electron is located than what they had, 100 years ago. Trying to determine and understand the observations about electrons and how that matched with what the theory of the atom would look like. And it turns out the electron isn't just located in that diffuse cloud around there. It's not in some solar system orbit like we might think that the electron would be in, but there are a number of different locations that we might be able to most likely find the electron, and we call those orbitals. And when I say most likely, what I mean is that we can't always know, or we can't know exactly where an electron is located and understand things about its movement at the same time. Those two things turn out not to be knowable because if we try to learn one, we lose track of the other. And so that makes things a little more complicated. However, we can start to say, okay, where most probably might we find the electron? And we call those spaces orbitals. All right, and orbitals is just a fancy name for a location in space where we might be able to find an electron residing. So I like to think of it like this: you've got a house or an apartment or some place that you live, maybe a dorm room or a dorm building that you live in, and you know you're not always found in your bedroom or your dorm room. You might be found in the lounge, or you might be found in the living room, or you might be found in the kitchen. Um, those places are all still part of your house or part of your dorm or part of your apartment, but they are uniquely different spaces. And so these orbitals are different spaces around the nucleus where we might find the electron. And the simplest one is the space here that's just a spherical space or spherical volume around the nucleus. And in this picture, you notice we have this axis system. Well, right in the middle where they all intersect, that's where the nucleus would be. And the nucleus would be right in the center of that sphere, in center of that ball. And the electron could be anywhere within that space, within that spherical space. Then we have something called a p orbital, or a region in space that's shaped. I like to call it like a dumbbell, like you might lift weights, where you have a weight on each end and a bar in the middle. And it doesn't quite look like that, but you'll hear me call it a dumbbell a bunch of times. Where again we have this axis system, and right in the center is where you'd find the nucleus, and in this space, this p orbital, all right, we might find the electron here or within those two lobes of that particular orbital. And then we have a d orbital, and again we've got our axis system, and right where they all meet is going to be right where the nucleus would be. And in this p orbital, I like to say it's shaped almost like a clover leaf, like a four-leaf clover. The electron might be located in any one of those four regions of space around that nucleus. Now, it's even more complicated than that because now, any way that you rotate a sphere, you're always going to get a sphere. So there's only one type of s orbital, but it turns out there are three different types of p orbitals, three different regions in space that have a similar shape to this. One's going to be along the z-axis, one along the y, and one along the x. And then the d orbital is even more complicated than that. There are 5 different locations where you might find 5 different d orbitals where we might find the electron, and we can specify which electron's in which of those. It's going to be, what's different about them is where they're located relative to that axis system. So in a lot of ways, we can specify, or we can determine a region in space where we might most probably or most likely find that electron. And in some ways, finding the region in space where an electron is located is very much like trying to write an address, where you might want to write. You might need to know the name of the person you're sending a letter to, and then you'd need to know a street address or a post office box. And then you need to know the city where the letter would be going to, or where the house would be, and you need to know the state, and then you need to know the zip code, and all that information narrows it down to one space. And that's really a lot of what we do. And I'm going to take some of these slides away so that you don't have to keep looking through them. And so, like I said before, with the s orbital is a region of space that's spherical, all right, can hold 2 electrons. There's only one of them. No matter how you rotate that spherical region in space, it's always going to look the same. Then we take the p orbital, and it turns out that there are 3 different spaces that correspond to a p orbital around the nucleus. All right? 3 different p orbitals. Each one can house 2 electrons. So it's almost like saying, okay, at this level there are 3 different rooms in the atom where the electrons might be located. Each room can hold 2 people. So, this might be something that lives in an s orbital that's living in a specific room. Something that's living in a p orbital is in a specific room, but there are 3 different rooms that are equivalent to a p orbital. And we've got the d orbital, and there are 5 different orientations, or 5 different d orbitals that we might find. Each one can house 2 people or 2 electrons. Sorry, I'm into my analogy about people. And right now, a lot of times, it feels like we have a lot of people in every space because we're all sharing a space and not really going anywhere. And I know you're probably all in the same boat as that. But each of those 5 d orbitals can hold 2 electrons. So, the d orbitals, those rooms in the atom, can hold up to 10 electrons total. All right, and it turns out that it's not just a game of figuring out, okay, what's the shape of the region in space where the electron might be located, and trying to determine what that is, but there are multiple different s orbitals, and there are multiple different p orbitals, and there are multiple different d orbitals. And what I mean by that is that in an atom there are going to be different s orbitals. There's going to be the 1s orbital, which is the s orbital that's closest to the nucleus, and then there's going to be a 2s orbital, which is the orbital that's a little bit further away. 3, 4, 5, 6 s orbitals, and notice that each one of them corresponds to, as we get to a larger, what we call energy level, all right, that number in front of that s, as we get to a larger energy level, notice that the electron can be further away from the nucleus. And so generally what we'll say is the electrons that have more energy are the ones that are found further away from the nucleus. So electrons that live in the 6s orbital have more energy than the electrons that live in the 1s orbital. Now remember, we've talked all along this semester about energy and how, a lot of times the way that energy works is that things don't like to have a lot of energy. They would much prefer to have less energy. So electrons in the 6s orbital tend to be a little less stable than the ones that are in the 1s orbital, and so they tend to be a little more reactive, or they are much more easily lost during a redox process. So that's just a little bit of more detail about electrons. We're going to keep talking more and more about electrons and how that relates to some of the properties that we see. And in particular, we're going to come back and tie this to luminol, trying to determine, why does luminol give off that blue glow? Or, whenever we do the multicolored flame, or you do any flame, why can you see the flame? Why is it orange or yellow? Or why, whenever we put potassium in it, does it turn purple? That's all going to be tied to where these electrons are located and the movement of electrons from one of these orbitals to another. But we have to be able to specify exactly what electrons are in what orbital first. So that's going to be the next part.